So we're talking about electric current. Now, electric current is the rate of flow of charge. What does that mean? Whenever you have electrons, charge flowing through a conductor within a specific time period, we call it is electric current. So how can we formulate this? So firstly, the current is shown by the symbol I, and it's measured in amps, right? A is the unit of current. We also have charge. Charge is Q measured in coulombs. And we also have time, which is T measured in seconds. So we're looking at electric current as how many charge per second is flowing through a conductor, right? So how many individual charges are flowing through a conductor at a checkpoint within a specific period of time. Say, for example, you're simply counting the number of cars passing through a checkpoint, and that tells you how busy the traffic is or the flow of traffic, isn't it? The same idea here. So when you look at this, the current is a rate of flow of charge. We can say current, which is I, is equal to Q divided by T. You see that division by time is because rate of flow, whenever we call rate of flow or rate of change, we divide that value by time. And that's how we have I equals Q by T. Now, we could also make Q the subject here. So Q is equal to IT. How did I do that? I cross multiply the time with the current and I got Q equals IT as well. So this is a very important formula to understand. But this is just one aspect of it. We have further aspect of it coming through. Let's check that out. You see, when we have a circuit, so I'm going to set up a quick circuit here. Here we have some cells. It is connected, a quick circuit right there. We have an ammeter measuring current, and we also have a resistor. All right, that's our resistor. And we have a full working circuit here. We have the voltage measured by the voltmeter right there. Okay, so this is a full circuit and the key is here, and I've given the key as well. So this is a open circuit. Now I will just close the circuit and we have current passing through this. Okay, so the ammeter is going to measure what? Our current I. The voltmeter is going to measure the voltage. Here we have the total voltage as well. The voltmeter measures the voltage across our resistor. The resistor has some resistance. Now from this, there is a particular law. We call it the Ohm's law. Okay, so what does the Ohm's law tell you? We're talking about the formula here. We say that if you increase the voltage by adding more batteries, suppose, the current will increase proportionally, right? So if we have the voltage, the current will increase proportionally, which means they both are directly proportional. If the voltage increases, the current will also increase proportionally, all right? Provided something happens, the temperature remains constant. Okay, so the voltage is proportional to the current provided the temperature is constant. Why is the temperature constant? Because we are referring to the temperature affecting the resistance. So in particular, when we talk about resistance and the temperature, there is a correlation. If the temperature increases, resistance will also increase. So we're saying that the temperature is not increasing for now, so the resistance is constant, all right? The resistance becomes constant, and that is where voltage is proportional to the current. And here is V equals Ri. This is very similar to Y equals mx. Do you guys remember y equals mx? It's the straight line graph, isn't it? So let's say this is our vertical and horizontal axis. This is our y value. This is our x value. And if I draw a line, we have the gradient to be the value of m, correct? The same way, instead of y, if we have voltage here and instead of x, we have current I here, the resistance becomes the gradient in this case. So that becomes our gradient over there, which is constant provided it is proportional, provided the temperature remains the same. So that's the idea of the ohmic conductor coming in. So I want you guys to understand this formula could also be, it's very famous formula. It could be written as V equals IR. That's the usual writing of it, but voltage is proportional to the current provided the resistance is constant. How does a resistance become constant? We assume that the temperature don't increase. Okay, now I want you guys to play around with this formula. Check this out. Do you guys see here we have I equals Q by T? Yeah, that formula, look at that formula coming together with this formula. Let's join them up. So we already looked at I equals Q by T, and we also know V equals IR. So I just want you guys to replace that I equals Q by T onto the other side. So look at this. We can have V equals, and instead of this I here, I'm going to replace the whole of Q by T there. So what are we going to get? QR divided by T. So this is also a formula for you guys to work out what? Voltage, provided the charge is given, the resistance is given, and T is also given to us. So this is something to keep in mind. But most importantly, if I go back, Ohm's law is what majority of the questions are based on. So you want to make sure you understand this. Voltage is directly proportional to the current.